Episode 9, Anomaly 13, the coma that refuses to disperse. From November 15th until today, we have received continuous image sequences from observatories and amateurs across Thailand, Spain, the Canary Islands, and several European stations. Across all these sources, the same unusual pattern appears: a coma that moves, rotates, and remains intact. No radial spreading, no expansion, and the entire structure travels as one unit with the nucleus. This is not the behavior of any known comet. Meanwhile, the brightness continues to rise steadily. The jets, at least 5 to 7 clear ones, remain sharp, symmetric, and non-dispersive. Periodic pulses appear. Loeb's article, 26th of November 2025, reports a cycle of approximately 16.6 hours, exactly what we predicted 2 weeks earlier. A 1 and a 2 remain positive. A 3 slightly negative, matching the micro-adjustments we forecast in advance. The core of Anomaly 13. The coma appears confined. It does not diffuse, does not open outward, and rotates together with the body. This behavior has no parallel in known cometary physics. The natural model, the only plausible physical explanation, the only natural scenario that could even partially match what we see, is an extreme form of dust trapping. 1. Electrically charged dust grains create gentle electrostatic cohesion. 2. Magnetic field lines from ion jets trap dust close to the nucleus. 3. Slow rotation pulls the coma along as a single envelope. But for this to work, the system would require a strong and stable magnetic field, uniform dust distribution, jets that remain unchanged for weeks, perfect symmetry in the coma. No documented comet has ever shown such behavior. Even Loeb notes explicitly that this pattern does not fit well within standard cometary models and calls for a new explanation. Our model, electromagnetic propulsion interpretation. The framework we proposed nearly 2 months ago explains all observed features simultaneously. 1. A contained electromagnetic field. If the object uses EM-based propulsion, ion thrust or guided plasma, it will naturally produce a magnetoplasma bubble around itself. Such a bubble confines particles close to the body. This yields the exact visual result: a stable, self-contained coma that does not disperse. 2. Rotation and pulses. A 16.6-hour cycle fits 2 scenarios in our model. Periodic thrust pulses used for stabilization and course adjustments. A controlled rotation that carries the coma inward, outward, in perfect sync with the nucleus. 3. Stable jets. Symmetric jets at fixed angles persisting for weeks, including a stable anti-solar jet, are unprecedented in natural comets, but expected in a controlled system. 4. Comparison with known comets. Shoemaker-Levy 9, Hale-Bopp, NEOWISE, all displayed expanding, diffusing comae with highly variable jets driven by solar heating. 3. I-Atlas, in contrast, shows no diffusion, maintains structural stability, displays jets that barely react to the sun. This is a clear departure from natural comet behavior. Synthesis: why this matters. For the first time, we observe a long, uninterrupted sequence showing a stable coma, stable jets, symmetry, rotation synchronized with the coma, persistent pulses, clear mismatch with cometary physics, and full agreement with predictions made before the data was released. Everything that unfolded matched forecasts we made weeks in advance. Conclusion: we are documenting an object exhibiting behavior incompatible with established comet models, yet perfectly consistent with controlled electromagnetic propulsion, including pulses, rotational synchronization, and non-dispersive jets. The repeated confirmation of our predictions, made prior to public data, strengthens the conclusion that the technological model currently explains the observations more successfully than the natural one.